So we're going to talk about the Chapter 5 notes in this video, and I'm using the version that we went through in one of my Math 95 classes today. So the part that we did in class is already filled in, and you can see that on the video of class. We'll kind of talk about it a little bit, but I'm not going to go through every detail of those. So we started out here with a review of the Cartesian coordinate system, kind of this coordinate plane. We labeled the x and the y axes, the quadrants. So the quadrants are the four parts that the axes divide this plane into. We talked about numbering the axes. The origin is right in the middle where it's 0, 0. And then we talked about labeling those points, drawing points and labeling them. Right? Remembering that these are ordered pairs. Order matters, so the first number in the pair is always the x movement, how far left or right I move from the origin, and then the second number is how far up and down I go from that first point. So we labeled those. So if you were not there in class or need a little bit more of a refresher, you can go ahead and pause the video and kind of look at those. And as always, make a note if there's something that you don't understand. And we can go over it in office hours. You can ask me. You can also look back at the video from class. Then as we talked about in class, in a normal semester, we play a little game of Battleship to practice our coordinates. I didn't take that out this semester, but we were not able to do it, obviously. So then we talked about linear equations. We know an equation is linear because it has just x to the first power. It makes a straight line. In class, we filled in this chart for this equation, y equals 3x minus 2. So what we do is we take the x value we're given, we substitute that in for x, we figure out using order of operations what y would be. Okay, that gives us an ordered pair, an x and a y. We notice that some of these, the ones that are highlighted in green here, had y values that were too large for this graph that we had here. So we're not going to use those. We don't need all these points for a straight line because we only need any part of the line. We actually only need 2 points on the line, and then that creates the whole line. So these ones with the check marks are the ones we graphed. So we put these on the coordinate system. So we did, let's see, -1, -5, 0, -2, 1, 1, and 2, 4. Drew a line. My line got a little messy just because trying to do it on my little tablet is a little trickier than on paper, but we on paper you would want to make sure you use a straight edge to graph that, and so then we label it with the line. Okay, then there were a couple other examples that I said you could try on your own. So let's just do the first line here together, and then you can pause the video and I'll pause the video and fill the rest in, so when it keeps playing it will have all the answers filled in there. So again, my first x value here is -3, so I want -2 times -3 plus 1, right? So -2 times x, which is -3 plus 1. This is going to give me +6 plus 1, or 7. So my y is 7, my ordered pair is -3, 7. So go ahead and complete the rest of this table. So pause the video. When you start it up again, the table will be filled in. Okay, so hopefully you paused the video, tried these on your own. You can pause it here if you want so you can see it for a minute before I move it. Check your work. As always, we just substituted in for x, used order of operations to solve it. So this middle column here is my work column, right? Just shows all the work I did. And then I have my y value in my ordered pair. So when I look down at my graph, if I'm counting by ones, which you don't have to do, but I'm making each block 1, it only goes to 5 or -5 in each direction. So this ordered pair with the red X next to it would not fit there. Please do not add on boxes onto your, if you had a paper test or homework, do not just draw on extra boxes. So we're going to graph the rest of those, not the -3, 7, but the rest of them. Okay, so then if you go down here, I did graph these here. I didn't connect them yet because I wanted you to be able to see the points clearly before I mess it up with my poorly drawn line on this, but you can see where those points are. Again, you can see it makes a straight line, right? And you can see that there's this pattern. We talked about that pattern of the x's going up by a certain amount and the y's going up or down by a certain amount. In this case, the x's go up by 1, the y's go down by 2. Just to kind of connect that with the slope, right? If you look at this rise over run, we go down to right 1. So in an ordered pair, x is first, right? In the slope, the rise, the y is on top. But you can see it's that same pattern between each pair of dots. That's what makes a straight line. So now I'm going to attempt to draw a straight line on here. It's just a little harder than it is on paper. So there's that, and we have y equals negative 2x plus 1. So I'm labeling it. So there's my line for that. Okay, so I'm going to keep moving. If you needed more time to look at the chart, of course, rewind it and pause it for a minute. Okay, so here's one more, and we're going to talk about this one for a minute before I let you loose on it. You can see that there are no x values. So let's just use the space up above here to talk about this a little bit. So if I have y equals 1/2 x plus 1. Okay, and let me just write this a little more clearly so we know that the x goes right here. You know what? I'm just going to rewrite this whole thing. I want to make sure you see that the x goes right next to the 1/2. It's 1/2 times x. So let's pretend that we said x equals 1. Okay, what would happen? Well, we'd have y equals 1/2 times 1 plus 1. So y equals 1/2 plus 1, which is 1.5 or 3/2. Okay, so think about this is 1/2, this is 2/2 altogether, that's 3/2. So my ordered pair would be 1, 3/2, or 1, 3/2 is the same as 1.5. Now I can graph that, okay? If I'm going to graph that, that means I'm going over to the right 1 box and I'm going up 1.5 boxes. So my point would end up between two lines, and that's fine. That's perfectly acceptable. Not always the easiest to graph though, right? And especially imagine if instead of 1.5, it was a slightly different equation. We ended up with 1.8 or 1.25 or something that was a little bit harder to estimate. So when we have a fraction in front of the x, what would be really nice is if we could pick values of x so that I only get integers. Okay, so let's say if I want to have 1/2 times some value of x, it would be great if this thing became an integer instead of a fraction. Well, what would that have to look like? My denominator would have to cancel out. So what kind of numbers would be best to plug in for x if I want that denominator to cancel out? Well, you can imagine that things like 2, something like 2 and 2 would cancel out. Or if I had 4, 2 goes into 2 once, 2 goes into 4 twice, that would cancel out, right? Or 6. So what I want to have are multiples of the denominator, just like we do in that LCD method for solving equations with fractions in them. We want to multiply by a least common multiple, right? So if it's a multiple, then that denominator will cancel out. So that's what we're going to do. So in this case, it's even numbers. So I'm going to go, they can be negative too. So I'm going to, actually, let me erase this. Okay, so I'm going to start with, I'm just going to do not negatives. I'm just going to do evens. So I'm going to start with -4, -2, 0, 2, and 4. Okay, I don't want to do odd numbers because if I do 1, for example, I'll get a half here and then have to add 1. If I do 3, I'll have 3/2 and have to add 1. So I want multiples of the denominator. So let's see what happens. We have 1/2 times -4, or I can write it as -4 over 1. Plus 1. What happens to my 2 and my -4? Well, 2 goes into 2 once, 2 goes into -4, -2 times. So I have -2 plus 1 equals -1. I have a nice integer, so now my ordered pair is relatively easy to graph, just as easy as anything else, because it's integers. Okay, so the important part here, the new part, is realizing that you want to, when you have a fraction there, you want to plug in multiples of your denominator. So if you had 1/3 there instead of a half, you'd want to plug in things like 3 or 6 or 9 or -3, -6, -9. Okay, so go ahead and try the rest of this chart. I'm going to pause it and do it. You pause it and try it, and then you can check your answers. Okay, so here's the completed chart. I have the work for each one. As we did before, if we're multiplying by a fraction, we're multiplying an integer by a fraction, it's easier just to write that integer as a fraction, so that's what I've done here. In those cases, canceled things out. In every case, the denominator cancels out because what I'm multiplying by is a multiple of that denominator. Do my work, here are my y values, here are my ordered pairs. Again, if you need to look at this a little more closely, just pause the video so you have more time. Then I took those ordered pairs, graphed them all on my graph, drew my straight line, labeled. Okay? All right, so doing that XY chart, we did a couple of examples here with linear equations. Then we moved on to more graphing in class. We didn't do this one just because that is actually the same example as the first one. So one of the classes did it, the other one didn't. Then we did an absolute value equation, and then we did a quadratic equation, right? So you need to know the difference between those, need to be able to identify them from looking at the equation. So a linear equation just has x to the first power. An absolute value equation has an absolute value. A quadratic equation has an x squared in it. Okay. Then we talked about slope-intercept form quite a bit and what that means. So let's look at this other example, number 6, that we didn't do. So remember, if we're going to put something in slope-intercept form, we want to get y by itself. We want it y equals mx plus b. So here's my y. I'm going to move other terms away first. So I'm going to move 3x to the other side by adding it. I cannot combine it with the 8 because they're not like terms. I can write them in either order, but knowing that I want to get to something where this is y equals mx plus b, I'm going to write the x term first and then the 8. So 3x plus 8. And then I'm going to divide. We said we want to put this under each term separately. That allows us to not only keep that format, but also simplify as we can. So this is going to be a 4. So 3/2 x plus 4 is my equation. So I'm going to go down here now. Y equals 3/2 x plus 4 is my equation here. So remember, y equals mx plus b, right? And the m and the b are my slope and my y-intercept that I'm going to use as another alternative method to graphing. This only works with linear equations. So my y-intercept is the b. So remember, this is the b. So this is going to be 4, positive 4. My slope is positive 3/2. So what does the slope mean? Well, again, I still write rise over run right next to it to remind myself. So 3 is the rise, it's positive. That means we're going up 3. Run is 2, that's positive, so we're going to the right 2. Okay, so that's how I am moving from one point to the next. So I'm going to draw in my axes here, and then I will number them, a couple in each direction at least, so I know what I'm counting by. I'm going to count by ones. So 2, 4, 6. Okay, so I start out with a y-intercept. That's my first point. It's positive 4, so it goes at positive 4 on the y-axis. Then my slope is 3/2. Now, depending on where you drew your axes here, You may be able to go up 3 and right 2. If you notice, I can't. Okay, I ran out of space. So remember we said that you can also reverse both directions. So instead of going up, I could go down 3. Instead of going right 2, I could go left 2. What that really means is you'd have -3 over -2. A negative divided by a negative is a positive, right? So it means the same thing. So from here, I can go down 3 and then left 2, and there's my next point. And you can see if I had this point first, I would have gone up 3 and right 2, right? So down 3, left 2, there's my point. And you can see that this is, again, making a line that I'm going to attempt to connect somewhat straight here. So there's my straight line that it makes. Again, if I had preferred the other method of doing an XY chart, I could have done that and gotten exactly the same answer. And in that case, I would have wanted to, again, substitute in numbers for X that were multiples of 2, right? Okay, so then in my Tuesday, Thursday class, we didn't get to this in class. In my Wednesday class, we did. So we graphed these next two examples look a little different. It's just y equals -3 here. There's not an x even in it. But if you kind of match it up with y equals mx plus b, you can see there's no x term. M is 0 essentially, but b would be -3. So what we said though is when you have one like this, do a little chart if you need to. So my chart over here, my xy chart, I put in some values of x and then I look at this equation and it doesn't even have x in it. So I don't have anywhere to even substitute that -2, that -1, that 0 in there. My equation just says y is -3, always, end of story, doesn't ever change. So I put -3 in for all my y's. When I graph each of these ordered pairs, right, so etc., I graph each of those and I get this red line. It's a straight line, it's a horizontal line at y equals -3, as if all of those points have come down -3. And then if we have x equals 2, that also looks weird. This really looks weird because it's not even y equals. So again, think of this rule as saying that x equals 2 always. So the only value I can ever have of x is 2. It doesn't matter what y is. I can plug anything in for my y. So again, if I go to graph this now, so I go to graph this, I have 2, 1, 2, 2, 1, sorry, 2, 2, hold on. I am not thinking about what I'm doing here, am I? Okay, let's try this again. Over 2, up 1. I was right first. Over 2, up 2. Over 2, up 3. You can see what we're getting here, right? We're getting I'm going to do this in red so we can distinguish it from the axes. I'm getting this vertical line at x equals 2. Every point on this line has an x value of 2. No matter what the y is. So when you have x equals a number or y equals a number, it's always going to be either a horizontal or vertical line. Especially in Math 120, and here too we'll talk a little bit, it's good to know which is which, but if you can't remember which one's horizontal and vertical, just make a little chart like this and it will come right out. You'll know that one of them is always going to be the same number no matter what the other one is. Okay, so the last thing we're going to talk about here are graphing applications. So we're looking at some real life examples where we could use graphs and equations to model what's happening. Okay, so you go to the store to buy Honeycrisp apples. They're priced at $2 per pound. Using y for the total cost and x for the number of pounds of apples, write an equation that gives the cost, y, of buying X pounds of apples. So sometimes I think it's easier to fill out the little table first. Okay, so if I buy 0 pounds of apples, if I go in and I don't end up buying anything, well, my cost is going to be $0, right? That sort of makes sense. Okay, now I go and I buy 1 pound of apples. It's $2 for every pound. So if we think about it, my total cost is going to be $2. Okay, now each of these is kind of separate. It's not like I'm buying 2 more pounds. Now what if I went in instead and bought 2 pounds? Well, each pound would be $2. So here's 1 pound. Here's another pound. Each of those is $2. So it's going to be $4, right? Think about that sort of pattern that I mentioned the other day where we have, the value of the item times how many there are. So I have 3 pounds. Each one is $2. 3 times 2 is 6, 8, 10. So as we're filling this out, we're kind of realizing that it's the number of pounds times $2, right? Well, in number 1, it gives us a variable to use for the number of pounds of apples, x, right? So here in this place, I would put x. So my y, my cost, is going to be 2 times x, $2 times however many pounds I have. Okay, now I'm going to go ahead and graph this. Where do I get my order pairs from? Well, I get them from this table. I'm plugging in x's, I was getting out y's. You can check these now with our equation. You could have done this in either order, A or B. But if I plug 1 in for x, 2 times 1 is 2, 2 times 2 is 4, etc. So x equals, so I have 0, 0. Now notice that I'm just using the first quadrant. If you think about a coordinate plane, okay, you can see that what I'm using is just this part right here. So this would be a perfect example of in class, we'd talk about y, I'd get you guys to think about y. Unfortunately, we can't do that this way, but if you think about why that is, it's because the other quadrants all have negatives, either x or y or both. I'm not going to have negative number of pounds of apples. I'm not going to have a negative cost. So I only can use positives here. So I go ahead and graph this. So 0, 0, 1, 2. So I'm just looking at my points up there. 2, 4, 3, 6, 4, 8, 5, 10. Okay, here's my line. Theoretically goes on forever, right? You could buy 478 pounds of apples. You'd multiply that by 2 to get your cost. Okay, this x right here is the number of pounds of apples. And the y value is the cost. Okay, so this is the beauty. This is why we use equations, right? We model things. This is called mathematical modeling. We're taking a situation and modeling it with an equation. And then we can use that equation to show what's happening visually. We can predict things, all different things we can do with that. All right, so next we're going to talk about Math Club t-shirts. So go ahead and read through it and try to just see if you can figure out something about that equation. Even if you can't get the whole thing right now, see what you can figure out about it. Okay, so think about a little bit about what we were doing in chapter 4 also here. So kind of, taking those words and putting them into an equation. So C is the total cost, T is the number of shirts. Write an equation that gives the cost. So you see up here the information that says the cost will be $3 per shirt plus a $20 setup fee. So think about what that means. No matter however many shirts I do, there's a $20 setup fee no matter what. That's constant. And then also, every shirt costs $3. So this plus, or sort of my and then also, means there's 2 parts, right? So C is the cost. The total cost is going to be some amount per shirt plus the $20. $20 is not changing. It does not matter how many shirts I have. The other part is $3 per shirt. So if it's 1 shirt, it's $3. If it's 2 shirts, it's $6, right? You can see again, we're taking that number of shirts, multiplying it by that value. So I would get 3T. So the cost is 3 times the number of shirts plus $20. Now again, when you're creating a table, you may find it easier to do the table first and then come up with the equation. So for example, if I had, I'm not going to have negatives again. If I had some shirts here, my cost, so here I'm going to have sort of this work area. But if I didn't have that, I could just think, okay, I'm buying 0 shirts. I had that setup fee still. They set it up for me. It's still going to be $20. I buy 1 shirt. How much is it? So you can kind of do that part first and then work backwards to think, what did I do? How do I write that as an equation? Or if you have the equation first, we can do our usual where we substitute in, right? So this is going to be 3 times 1 plus 20. So $20 setup fee plus 1 shirt is going to be $23. This is going to be $26. Okay, 3 times 3 plus 20 is 9 plus 20 is going to be $29. So we can see some choices there. Now, to graph the values, it's going to be a little different this time. My Y value, or my C in this case we're calling it, cannot be by ones because I won't make it up there. And again, we only need the first quadrant. I can put my axes right here as if I'm just taking that first quadrant, because I'm not going to have negative numbers of shirts or negative cost. This is my cost, and this is my number of shirts down here. So I could, count by ones here. Again, I can just put the evens on. And then my cost, even for 0, it's $20. It's going to keep going up. So I'm going to go by 5s and hope that gives us enough values here to get a good sense of what's happening. Okay, so 0, 20, 1 was 23. We have to just kind of estimate, right? 2 is 26, 3 is 29. That's as far as we went. We could add other values to our chart too, just to get an idea. I could say, well, how about 10, just so I know. Well, 3 times 10 plus 20. This is 30 plus 20, which is going to be 50. So that gives me an idea, sort of, it's a little bit easier to graph also if you kind of know where you're headed, right? So I'm starting out like this. Here's my C equals 3t plus 20. And then again, all those points on there would be a value. Okay, so that's the end of our notes for chapter 5. Okay, please let me know if you have any questions as you either go through the notes or do the homework. Thanks, guys.